All right, it's time. Welcome back to everybody. I have posted our first homework assignment. It will be due on Wednesday, as always, so that the usual schedule will be homework due every Wednesday and the quiz on Friday. So check it out. It's going to be due, you should submit it on Gradescope. The questions are from the textbook, so no hurry, but you can get started on it as soon as you're ready. All right, let's just get down to it. We were talking about DFAs last time. I had some kind of a weird thing going on with my mouth, and I had an appointment yesterday, which is why I feel like I sound weird. I guess you don't know what I usually sound like, but some of my consonants are not coming out right, so my apologies. I'll be back to normal in a few days. We're talking about DFAs, all right? And we at the end last time we did several examples. I just got a couple more examples, and then I have some for you all to try. So let's try just some examples here. How about a DFA to accept strings like AB to the N? So that is, the string has to start with A, and then after the first A, it has all B's. That's the idea. Starts with A, and then everything else is a B. A, B to the N. All right. So I hope you remember at least the basics from last time. The DFA is going to look like one of these diagrams with states. Those are sort of like the big circles, and they have arrows that are called the transitions. One of the difficult things that comes when you're trying to make these DFA diagrams is you have to decide what should the states be. And this is something that you just have to kind of get used to. In my opinion, what's going on here, there's kind of two things going on here. First, it has to start with A. It starts with A, if I were to say this in words, and then has all B's, right? Otherwise, it should reject. So my construction of the diagram is gonna be kind of inspired by this little slogan here. It has to start with the A and then has all B's, otherwise the string should be rejected. So I'm going to have a rejection state. This is not the starting state, but I'll call this a failure state, all right? And the string where you start, let's say this is gonna be the starting state, it must start with an A, otherwise it should fail. So I'm going to say sort of an A like that to something else, but then a B like that, right? This much of the diagram is saying it has to start with an A or else it's going to fail, all right? It starts with an A, and then it has all B's. So we'll have to think about that, but I suppose there has to be another state over here, right? And now let's try to fill in some more arrows. Remember, in a DFA, every state must have two outgoing arrows, or one outgoing arrow per letter. So in this case, I'm just talking about A's and B's. So this has an outgoing A and B. What about from here? Where should the arrows go from here? This is a state which is intended to be a sort of a permanent failure state. Anyone want to suggest? Yeah?
Just going back into it.
Yeah, I'm going to put both the A and the B sort of a looped arrow like this. That will make it into this, like I said, I want it to be like a permanent failure state. And what about that other state over here? So I don't know what, here I gave it a little name just to remind myself of what it's supposed to mean. This state, I don't know what to say here. I would just say you sort of begin here and then immediately leave, right? So we're never coming back to this state. It just this state is just sort of helping you to decide what the first letter is, right? And then what about this state? Anybody want to suggest I need two arrows here. Should it an arrow with an A on it? Anybody want to say what should happen? If I go over here and then see an A, should it be a loop here? Maybe go back to that one or down to the bottom? What do you think? Yeah, down to the bottom, right? Because what should be accepted is it starts with A and then has all B's. So if you see an A and then another A, that should be a failure. So I'm going to put A going down like that. And what about a B from that state? I want it to be accepted if it sees B's. Anybody got an idea? Yeah?
It just goes back to itself.
Yeah, I think this will work. And then this is going to be my accepting state. And I think that'll do it. Starts with A and then has all B's. That's what A, B to the N means. I think that does it, right? If we begin with A and then have some B's, it'll just do this and be accepted. But if we begin with A and then have some B's but A, that'll fail. And of course, if we don't begin with A at all, that will fail. One thing that's a little sort of, I suppose, slightly weird technicality, if you have just A and that's it, it will be accepted here. Although that also is the desired behavior, because here you could let N be 0, and then A, just A by itself would still be acceptable in this category of strings. All right, so that's that. I feel good about that one. Any thoughts about that? Let's try one more, and then, like I said, I got some for you all to try. How about accepts if there's an even number of A's and just any number of B's, right? So for the A's, I have to keep track of even versus odd, but the B's I just don't care about. You want an even number of A's, all right? As we did last time, we saw last time, when you want something involving like evens and odds, then typically, sorry, I'm just realizing I copied down from my paper the wrong thing. It doesn't really matter. This is not what it says on my paper, but nobody has to know. If you want to talk about, say, evens versus odds, the standard way to do that is with two states and arrows going back and forth. This is what you should always have in mind if you're ever considering something about evens versus odds. And in this case, it's about the number of A's that you see there. And so basically, like my basic setup is going to involve something like this. Now, if that's the whole thing, then all it does is keep track of evens versus odds. And if I start over here, then this one here means even A's, and this one here means odd A's, right? If you start on this one, then this is for 1 or 3 could get you here, or 5 could get you here, and so on. And the even numbers would be that state over there. What about this any number of B's? You need to add in some B arrows. I actually don't think you need another state in this case, but you need to add in some B arrows, which make it so that the B's are just kind of completely ignored. Anybody see how to do that? Yeah?
Just have the B's go back into themselves.
Yeah, the B's should just both be looping edges like this. So the B's, this machine sort of ignores the B's in the sense that every time you read a new B, it just doesn't do anything. It stays in the same spot wherever it was before. All right? Yeah, and I think that'll do it for this one. Anybody, there's actually one ingredient missing here. Anybody see something? See something, say something? Yeah? Yeah, you have to say what is the accepting state. And actually, it hasn't come up, but you are allowed in a DFA to have several accepting states. There doesn't have to be just one accepting state. But anyway, which one should it be? Yeah, the one on the left, just because I said even number of A's. The one on the left should be accepting. All right, great. Any vague questions? All right, I got some for you all to try. So I like to do this. I like to do this every time, although it doesn't always happen. I'm going to give you some for you to try. I'm not going to like collect these or anything, but I'm going to walk around and see how you're doing. And I hope that you will feel free to ask questions if you got any. And feel free to chat with your friends about it also. So I have 4 different ones for you all to try. First one, accepts anything. All of these are on the alphabet A, B. Accepts anything starting with A. Next, anything ending with A. Next, anything starting and ending with A. And then finally, anything starting or ending with A. All right, these are all kind of simple variations, although you'll see actually the diagrams are going to look fairly different from one another. It's not possible to just kind of tweak a little thing from here to there. All right, see what you think. I'll give you a few moments and then I'll come around and see how you're doing. I know how to do that, but every state needs two outgoing arrows, like one for each label. So here you have a B, what happens for here and A? Yeah. How's it going? Perfect. Yeah, great. All right. Okay. All right. How's it going? Which one's going to be accepted? Yeah, good. And then this one needs arrows, like outgoing arrows from there. How's it going? This is good. You need these two states need outgoing arrows. Usually we put I would just run okay? This one. Let's see. We're starting and ending with A. That's good. Still good? Yeah. Yeah, this one's a little. Unfortunately, it doesn't really look like this. Yeah. I would say, in terms of like labeling my states, it's kind of. I think you could do it in two states. One being like it didn't end in A. Okay. It did end in A. I think you should start in the non-accepted one because where you start is like a empty string, which does not end with A. Okay. Yeah, that was great.
Still here?
So this will accept just B, because it will be here. I think the change. Don't put B here. Yeah, I think that might do it. Still good here?
I think it's hard.
Which one are you doing?
I'm doing not the second.
The second. Yeah, this is pretty good. I think this would not accept AA because you've got A and then A.
I'm finding trouble figuring out which one's like the last one, the last
Mhm.
character.
Well, I think this is pretty close to good. You just want to make it so that with that A right there, I think you shouldn't. So this state represents the last name is A. And if you're here and you see another A,
Oh, actually, yeah.
then it still makes the last name good A, so it serves. Yeah. Still good? What you got? 39 days. It's not necessary. I think actually in this one, I think you really probably need two states. You can say this state represents something which is not in the state, and this represents something which is in the state. When you start, you see B. You imagine when you start, it doesn't. You see B, it still doesn't. Let's take a couple more minutes and then we'll chat about them. It's fine if you didn't quite make it all the way through. How's it going? I would say, I'm not sure, like these, I think right inside are just sort of like a name for you to help you know what it's supposed to represent. So, I mean, you could write whatever you want in there. I would say you can do this one using two states, where the first state represents a string which doesn't end with A. The second one represents a string which does end with A. And then you just have to think about, so like if this one means it doesn't end with A, and then you see a B, where should the B send you? So I just mean like where, if you have these two states, and this one means it doesn't end with A, and then you see a B, then I think it still doesn't end with A.
Yeah.
So that means that the arrow should move back. It's an A, right? And then think about, okay, if you already have a string that ends with A, and you see another A, then
It still is.
it still has an A. Yeah, so that means it goes back. Right, okay. Yeah, that's pretty much it. Decide which is the acceptable.
Okay.
All All right, can we talk about these? I know not everybody has made it all the way through, and that's fine. Like I said before, these do take some bit of getting used to, and it's kind of like learning a programming language. Like you have to kind of get a feel for how to express yourself in the language of a DFA, which is a very different kind of language from how you ordinarily express yourself, I imagine. How about starting with A? Pretty much everybody I saw worked their way through this one. In this case, I think it's best to just have sort of a branching path at the very beginning. If it does start with A, it goes up here and should be accepted no matter what. So I'm going to do this. This is like a permanent accepting state. And if it does start with B, it should be rejected no matter what. And so this here is like a permanent rejecting state. So this is what I say for starts with A. Right? I think this is pretty much what I saw as I was walking around. Anybody got questions about that one? There are, when you're writing DFAs, it is possible for you to write something that doesn't look like mine, but is still a correct answer. I think this is the simplest way that you can make this, but there are other sort of more ridiculous ways you could make an equivalent DFA, I'm sure. Okay, what else? How about, sorry, I've lost my assignment. Ending with A, all right. This one, unfortunately, looks completely different. I would imagine, or the way that I think of this, is two states where the first state means, represents a string which sort of doesn't end with A. And the other state is it does end with A, right? And I start over here because the empty string doesn't end with A. And if I'm reading a string which doesn't end with A, but then I see an A, that means now it does end with A. If it doesn't end with A and then I see a B, then still it doesn't end with A. That's why I have a loop back here. And then over here, if my string does end with A and I see yet another A, then it still does end with A. So I put an A like that. And if my string ends with A, but then I read a B, now it doesn't end with A anymore. And so the B arrow goes back like this. And this is my DFA for that one. And it's supposed to accept when it ends with A, so that's like so. I hope you got something like that. Anybody got questions about this one? All right. Let's try the next one, which was with an and. Now you might think, oh, isn't there just some simple way for me to combine these two diagrams using the word and the answer is not really. We are actually going to talk about that, but there is no simple way to do it. So here I want starts and ends with A. It is kind of a combination of these two diagrams in some way. First of all, you have to make sure that it starts with A, which means you should do some kind of a branch like this at the very beginning. I think that is still appropriate to do. That is to help you check if it starts with A or not. If it starts with a B, it has to go to this failure state. All right? So starts and ends with A. There has to be a state up there. Anybody work this out? What did you say from here? Maybe someone I haven't heard from, if it's possible. I know not everybody made it this far, which is fine. Yeah?
Make that an accepting state.
Okay, this new one I just did is accepting.
And then add two new states.
Two new states. Okay, like that?
And make the top one accepting as well.
Okay. All right.
B, go to your rejecting one, and then from there it's just your ends with A between those two on the right.
Okay, so this. So you mean like this?
Yeah.
And from here, B goes down?
Mm-hmm.
Yes. I think I agree. This seems more complicated than I was expecting. And what?
And then they'll both loop for.
I'm missing some arrows. Here, A, here, B. Yes. Does it have to be that complicated? I think I did. I think I did one that was a little easier. Although I think this is correct. So if it's right here detects if it starts with A. Now this is something that he has paid close attention to. Starts and ends with A. If the string is just A by itself, that should be accepted because A by itself does start and end with A. So that's why this is an accepted state. And then if you see some more A's, they should be accepted on the end, but if you see a B, it should be rejected unless you then see another A. I think I like this diagram. Did anybody come up with something different?
I did.
Yeah. Okay. I know these are, it's hard for me to ask you to, to describe this to me, but how many states did you use?
I have 4.
4, okay.
I have the starting state, which is a fail going in with a B path into another fail.
All right, so this is like how I had started before, like that?
Yeah.
Okay.
And then that's for starting A, and then it has a path with A into an accepting state.
So is this one here accepting?
No.
Okay.
It goes into an accepting
All right.
with A.
With an A.
And then that accepting state has an A that goes into itself and a B going back to the other one.
And this has a B like that.
Yeah.
All right. This one I like, although I think this one doesn't accept just A by itself.
Well, it has to start and end with A.
Right. So I suppose this is up to interpretation. In my opinion, the string A does start and end with A. Right? It's a little tricky to think about. Yeah, so this one I would say is great, although I would like it to accept the string A just by itself. Maybe I'll tell you what I had written down and see if anybody agrees or disagrees. I said, so I was similar to this, but, sorry. I made this accepting with an A, B, A, B. Did anybody write that? I think that this is correct, and maybe this is the simplest way that you can do it. So here, just plain A is accepted, and then after that, if you see B, it should not be accepted, but if you see another A, it should be accepted. So that makes it so that the last letter has to be an A. And the first letter has to be an A, of course, just because of this. Sorry, this downward arrow should have a B on it. All right. I think both of those are correct. To me, to anyone, I think the one on the right is a little simpler. But all right, great. That's a hard one. And let's talk about the last one. Starts or ends with a A. This one, here's what maybe I'll try and keep that on the screen. But the same thing, but with or. Here's what I got. See if you agree. I again started off with one of these kind of 2 branching paths, and then if it starts with an A, then it should, since I'm using or, if it starts with an A, it should automatically be accepted no matter what happens after that. All right? But if it starts with a B, it should only be accepted if it eventually ends with an A. And to make that happen, I did this. So this says you can start with a B if you want to, but then you have to have an A and end there, or maybe have more A's. Or you could have a B as long as you have an A afterwards, which makes it so that it ends with an A. So this is what I got for that one. Maybe some of you got some kind of variation of that, which is probably also correct, or maybe incorrect. All right. Any thoughts about that? Yeah.
Could you loop like that bottom one for B going back?
Here. Yes. Yeah, thank you. I have no outgoing B arrow. Is that what you mean? Yeah, right. So this one, the outgoing B arrow on that one should be a loop back. Thanks. Excellent. Now, you agree? All right. Thank you. All right. Great. Okay, let's talk. So the homework that's due for Wednesday is going to have several problems of this type, just to give you some more practice. It does take some getting used to, like I said. I would like to try and ask sort of a big question that we're going to come back to eventually, but this is something that I would like us to start thinking about. Big question is sort of like, what kinds of things is a DFA capable of analyzing? What I mean by that is, you know, even versus odd. We have seen it is possible to make a DFA which somehow decides if something or other is even versus odd. It's also possible to decide something like sort of starts and ends, right? That kind of a thing. These are kind of a theme among the DFAs that we've done so far. Although DFAs are so simple that I think it would be unreasonable to think a DFA could just like analyze anything you wanted, right? Because a DFA is very, very primitive in terms of the kinds of operations that it can do. All it can do is read one letter at a time and just go one this way or that way, right? Here's something. Even versus odd, you could think of this as like another maybe more sophisticated way of discussing even versus odd is this is about divisibility by, I didn't write that word correctly, divisibility by 2, right? That's what it means to be even versus odd. And the standard, you know, even versus odd machine, if I'm doing only one letter, then it's just that, right? Where if you want to accept evens, you would make the one on the left accepting. If you want to accept odds, you make the one on the right accepting. Is it possible can we make a DFA for a to the n if n is divisible by 3? Even is like divisible by 2, right? And it's not so hard. Can anyone suggest a simple variation on this this basic thing, but make it so that it only accepts when it's divisible by 3, not by 2? Yeah?
Just add a third state.
Add a third state, and then how the arrow's going to go.
Just cycle through that one.
Yeah, right. You want the arrows to go kind of like in a circle. So oops, this would look like kind of that, right? So now it's accepted when you have no A's, but then to make it accepted again, you got to do 3 or 6 or 9, etc. So this will accept any power of A when n is divisible by 3. Could you do this for divisible by 4? Yes, you could. You make a sort of big circle with 4 things in it, etc. All right, so DFAs actually can check various sort of divisibility properties. Divisibility by whatever you like, right? By 2, 3, 4, whatever. Do you think it could measure if some number is divisible by 2 and also divisible by 5, say? Yeah, probably. I mean, we've already done some examples where you combine things using and somehow. It seems reasonable that you could, or you could probably even do a DFA, which is, maybe can anyone suggest, here is n is divisible by 3. Could I make a DFA that accepts only when n is not divisible by 3 and rejects when it is? How would you do that? You got an idea?
You just flip the accepting and rejecting.
Yeah. You just make these ones accepting and this one rejecting, right? So really lots of questions about divisibility by something, or maybe testing if something is not divisible, is or is not, that kind of thing. DFAs can do all of that. What about, here's something to me, sounds quite a bit more complicated. How about a to the n if n is a prime number? Now we're talking about something that, in my opinion, is much more complicated. Prime number means it is only divisible by 1 and itself. To me, there's no obvious way to do that with some kind of circular diagram like this. I mean, this diagram specifically works for divisibility by 3 and nothing else, right? I could make another diagram to test if it's divisible by 4 and another one to test if it's divisible by 5. To test if something is prime, really you need to check all possible divisors, which would somehow, I mean, the stupidest way I can think of would be to chain together all of those cyclical diagrams, but you're not allowed to have infinitely many things in a DFA. This should seem far more complicated, and I will just tell you, this is a little spoiler alert. This is impossible using a DFA. Right? Of course, in real life, it is possible to tell if a number is prime or not with a real computer, say. But that's because a real computer is more capable than a DFA. Like your real computer has more capabilities than the DFA. The DFA is like a very simple kind of a thing. But these are questions that we are going to try to discuss as we go along. What are the limitations of DFAs? They do have some fairly, fairly significant limitations, and this is one example of a question that cannot be answered by a DFA. But we'll leave that for later. We got 15 minutes remaining, 13 minutes remaining. I thought I would like to show DFAs actually are quite capable of doing things, and even they are capable of making certain calculations or computations which are kind of things that are kind of hard for human beings to do. And I wanted to do one example of that, and I think we can do it in our remaining time here. So this is a cute DFA for binary numbers. Maybe I'll just give a quick review of binary numbers. I hope that you're all familiar with binary numbers, even just a little bit. I'm not going to say anything too fancy about this, but the binary number system is just a different way of writing numbers. So for us, ordinary usage, when I talk about numbers, I always write them in their decimal representation, meaning base 10. So you count decimal numbers like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when you get to 9, there is no other symbol to use, and so you carry over to the next digit, and then you continue counting from that digit, right? This is the decimal system. The dec means 10, right? I don't mean decimal points. That's also uses the word decimal, but all right, that's the decimal system. What about the binary system? The binary system is based only on powers of 2 rather than powers of 10, and it means that you only ever use the symbols 0 and 1. And once you get to 1, there is no 2, you just carry over to the next digit. So the binary, if I count in binary, it looks like this: 0, then 1, and then I immediately carry over to the next digit, because in binary you never use any symbols other than 0 or 1. But anyway, then I continue to count from there. So after 10 comes 11. And then after 11, I have to carry again over to the next digit, like this, and so on. So I'm just going to write down, I might as well write these 12. 1, 1, 0, 1, 1, 1. And then I carry over on 8. 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. 1, 1, 0, 0, etc. All right, I just stopped because I felt like it. There's nothing special about those numbers. All right, this is the binary number system. It is just another way of writing numbers where you carry far more often. All right. Okay. Anyway, I would like a DFA which reads a binary number. So this DFA, its alphabet is not AB, its alphabet is 0 and 1. And it's going to read, the input string will be a number that looks like this. And it should be accepted when that number is divisible by 3. Right. This is what I meant by saying this is a DFA which can actually do a calculation which is kind of hard for human beings to do. For example, I'm writing a binary number here. Does anybody know if that number is divisible by 3 or not? The answer is no. You could Like everybody knows, there's some like rules for testing if a number is divisible by 3 or not, but they do not apply for binary numbers. And there is no good way to just look at that and know off the top of your head if it's divisible by 3. Like if I really had to do this, I suppose I would convert this back into a decimal number, which I would probably use a calculator to do. That also is not easy. And then I would use some kind of something that I know about base 10 numbers and divisibility by 3. But actually, I'm telling you, you can actually make a DFA which does this, which means if you have the diagram handy, you could actually just read this string one letter at a time and sort of follow the arrows, 0, 1, whatever, and it would be accepted or not based on if this thing is actually divisible by 3. This is kind of interesting in my opinion. What's even stranger about this, what even more remarkable that this is actually possible, is that a DFA always reads a string from left to right, which we all know, like when you read numbers, like if I'm talking about divisibility, especially when I'm reading numbers, I look on the right side first and read them that way. But actually this DFA is going to read left to right, which is even weirder in my opinion. All right, let's see if we can do this. We got 8 minutes. I don't know if that's actually enough time, but we will try to make a DFA like this. So to make such a DFA, what I want to think about is if you already have a binary number and then you read one more character on it. So if I have already read the number x, say, and then I see a 0, then how does this change the value? Right. What I mean is something like if I have 101 that I've already seen as far as my input string, which is a binary number. 101, of course, is the number 5. You can see this on the big list I wrote, if you like. And then if I read another 0, this number, reading a 0, becomes 1010, which you can also see on the list. This is 10 in decimal. So here I'm writing the decimal equivalent. That's 5. Maybe I'll put it in red. This is 10. Does this make any kind of sense? Can you say in general terms, what is the effect of reading a 0 on the last, in the last position? Anybody have an idea? Yeah?
If it's a 0, it's even. If it's a 1, it's odd.
I'm not sure. What I'm trying to talk about is if you've already seen this part and then you stick a 0 on the end, how does that change the value? Here the value of this was 5. When I stick a 0 on the end, it becomes 10, right? Versus, I could also stick a 1 on the end, right? If I stick a 1 on the end, now it says that. And this value is 11. Can anybody make sense of this? Can you predict somehow if you have a certain value and then you stick a 0 on the end, what's the effect of that going to be? Yeah. It doubles the number. Yeah, can you say something about why that might be true? That's true in this example, and actually that is generally what happens. When you stick a 0 on the end, it causes the number to double. Somebody else? Yeah?
Well, this is answering your question why it doubles it.
Yeah, why does it double?
It carries the ones over to the next position, which would multiply that too.
Yeah, it's like you're taking all the digits that you had originally and just like shifting them over left by one position. Now, everybody knows in decimal numbers, if you do that, the effect is to multiply the number by 10, right? Because you have sort of, if you think of each digit representing a power of 10, moving them over by one position to the left has the effect of jacking up all the powers of 10 by 1. Which is to say you multiplied everything through by 10. And that is the same in binary, but binary is based on 2 rather than 10. So here, can I say, maybe I'll say it this way, going from some string like x to x followed by 0, like in this case I had 101 became 1010, right? I'm thinking of starting with something and then just tacking a 0 onto the end. This has the effect of well, can I say it this way? Has the value of 2x, right? If you started with some number and then you just stick a 0 onto the end of it, the value that you end up with is 2 times that original number. Just like in base 10, if you stick an extra 0 on the right side of a number, that's the same as multiplying it by 10. All right. Can anyone say, similarly, if I go from x to x followed by a 1, so sticking a 1 on the end, has the value, can anybody say? Yeah?
2x plus 1.
2x plus 1. Yeah, it sounds like it's going to be more complicated, but it's not. It's just 1 more than it would have been if you stuck a 0 on the end. So it has the value of 2x plus 1, right? This is going to help us to think about the effect of the various like arrows in the DFA diagram, all right? So I think I'm going to maybe, I don't think we can do this in 4 minutes, but I'll get us started. So our diagram actually is only going to require 3 states. It's actually, as far as diagrams go, it's a very simple diagram. It has only 3 states, but this maybe should not be such a surprise to you. The 3 states represent one in which, I'm going to write them this way. I hope you don't mind my somewhat fancy terminology here. The first state is ones which are actually divisible by 3, and I'm going to write that in this way. X is congruent to 0 mod 3. I hope you're familiar with this mod business. It means that the remainder after you divide by 3 is 0. There are 2 other possibilities. So it could be that x is equal to 1 mod 3. That means it's 1 more than a multiple of 3, or it could be 2 more than a multiple of 3. All right. This 0 state is where I'm going to start. And that 0 state should also be the accepting state because remember the whole point of this DFA is it should be accepting strings which are divisible by 3. So I'm going to make that an accepting state. All right. The big question is where do the arrows go? And maybe I'll just, we'll finish this next time, but maybe I'll just get us started. How to tell where the arrows go. So let's look at arrows from the 0 state, x equals 0 mod 3. You have to think about, okay, this is a state in which if x is already divisible by 3, and we sort of stick on a 0, right? What is the effect of that? So if x is already divisible by 3, I can say something like x equals 3k. This is how you would write this out in your discrete math class. I'm sure you talked about such things. If x is divisible by 3, I can write x equals 3k. And then adding a 0 turns it into 2x, which of course is the same as 2 times 3k. And I ask you, is this number still divisible by 3? Or is it now 1 more than a multiple of 3? Or is it 2 more than a multiple of 3? What do you say? 2 times 3k? I say it is still a multiple of 3, right? It has this other 2 in it, but it doesn't matter. We start with a multiple of 3. It's still a multiple of 3. That means the arrow for a 0 looks like that. This says if we begin with a number that's divisible by 3 and we stick a 0 on the end, that's what this transition with a 0 means. That number will still be divisible by 3. All right? And we'll go through the details next time. But you can fill in all the other arrows here and get a very simple to use DFA. All right? Unfortunately, we got to cut it short here. Check out those homeworks. It'll be due on Wednesday, but I would be happy to chat about it if anybody got any questions. Otherwise, I hope you have a good weekend.